In this video, we are solving two questions from wave optics on a specific topic called polarization. So, both of them are simple theoretical questions. I will start explaining what do you mean by polarization and so that I can solve both the questions, right. So, polarization is a phenomena of restricting the vibrations of the light to only one plane. A light has vibrations in both the planes. This is vibration in one plane and the vibrations in the perpendicular plane is shown with a dot, that is an arrow into the paper. So, this is unpolarized light. So, when you pass it through a specific kind of a crystal or some kind of a structure, because of that property of the crystal or structure, it stops vibrations in one plane and allows the vibrations of only the other plane, like this. So, if this is having an amplitude A0, it will have an amplitude of A0 by root 2 only. Respectively, if it is having an intensity I0, intensity is square of amplitude, so it becomes I0 by 2. So, the amplitude becomes 1 by root 2 times and the intensity becomes I0 by 2 times when an unpolarized light of this becomes a polarized light like this. If you notice carefully, unpolarized light has vibrations in both the planes, whereas the polarized light has vibrations only in one plane. Thus, it is a less intense, half intense light only, right. So, if we have to talk about polarization, so if you continue this further, okay, and anyway, as we will solve the next problem, I will continue this further. This is called polarizer. The device who is able to polarize the light is called polarizer. To check whether this light is polarized or not, we can keep another crystal here. If that another crystal is perpendicular to the axis of the previous crystal, here I will get a darkness, all the light is stopped because the input here is having vibrations only in one plane. The axis of the second crystal is perpendicular to that, so that all the light is stopped. And there is another possibility. What is that another possibility is, let me just assume all the left side diagram is same. Here the crystal is like this, parallel to the previous crystal. Now all the light passes, it will have all the input of the previous, like whatever is available. Here also amplitude is A0 by root 2, intensity is I0 by 2. But there is something that is possible in between. What is in between is, this crystal what we have placed is making some angle with the axis like this. If this is the case, what is the amplitude that comes out is A0 by root 2 cos theta. So, this is an adjacent component only. Adjacent components will be passed because that adjacent component is only parallel to the axis. Similarly, intensity becomes I0 by 2 cos square theta. So, this second crystal is useful to check whether the input light is polarized or not. That is why it is called an analyzer. It is called an analyzer, right. So, if say for example, you have kept one more crystal, making an angle theta with the previous axis, with this axis, if it is making an angle theta. Here what will be, say theta dash, what will be the output is A0 by root 2 cos theta is input and cos theta dash. Out of this entire component only cos component will come out. Similarly, I0 by 2 cos square theta and cos square theta dash will be the output of that, right. So, stopping there at that particular part, I can solve first one problem that is available here. Let me just solve this problem for us, so that I can go ahead and think of solving the next problem. Yeah, let me just drag this problem here so that it becomes easy for us to understand that. Yeah, sorry. Yeah, let us see this question. What this question says. two polarides P1 and P2 are placed with their axis perpendicular to each other. So, two are perpendicular to each other, that means this is one polaroid kept like this, whose axis is like this, and the second one is perpendicular to this axis like this. This is P1, this is P2. Unpolarized light I2 is incident on this I1, I0. So, what is the light here that is striking this first one is an unpolarized light, that means having vibrations in both the planes. A third polarizer P3 is kept in between P1 and P2 such that its axis makes an angle 45 with P1. So, this is the axis of the P1. Now, you have kept another crystal P3 polarizer such that with the P1 it makes an angle 45 degree, right. Then the intensity transmitted through P2 is how much, right. So, here it comes like I0. What comes out of the first one is I0 by 2 as I have explained here, yes here. That I0 by 2 passes through a particular angle, therefore, it becomes I0 by 2 cos square theta. What comes out is I0 by 2 cos square theta, that acts like an input for this P2 crystal. So, the output of that will be I0 by 2 cos square theta and cos square theta dash. Between this axis and this axis there is an angle of another 45 degree, because the first and last are perpendicular to each other, first and middle are having an angle of 45. So, in between the angle between this axis and this axis is 45 degree. So, what is the output is after the third crystal or a polarizer, resultant intensity is I0 by 2 cos square theta 1 and cos square theta 2. Maximum intensity is given in the problem as I0 itself. So, it will remain same I0 by 2 cos square 45 and another cos square 45. So, I0 by 2 cos 45 is 1 by root 2. So, square is 1 by 2. So, it will become I0 by 8. So, the answer for this problem is I0 by 8. So, we have not actually solved any of the previous problems, with what we have intended to start, but we are solving all polarization problems at once. It is a good shot, right. So, the intensity, resultant intensity I have explained, it becomes I0 by 8. This is polarizations by polarizers. But here the problem is slightly different. Here what is the problem is unpolarized light incident from air on a plane surface of material of refractive index mu. At a particular angle of incidence I, it is found that reflected and refracted light rays are perpendicular to each other. Which of the following options are correct, right? So, that is, we have to say this is polarization, but this is polarization by reflection of light. How does that happen? Let me try to explain it to you, right. So, this is an incident surface, this is the incident light, the upper part is air, sorry, there is some slight disturbance, this is air, this is some another medium. So, this is the angle of incidence. The light that is striking this boundary is an unpolarized light. So, this is an extended normal. Light ray, when it is moving from rarer to denser medium, moves towards the normal. This is angle of refraction. Now, the light not only refracts, it reflects also. So, this is reflected light, this is refracted light, this is angle of reflection, refracting, this is refracted, this is reflecting. Angle of reflection equal to angle of incidence. We know that both of them are same. It is given that for a particular angle of incidence, the reflected and refracted light rays are perpendicular to each other. This is refracted, this is reflected, these are perpendicular to each other. So, if you notice carefully, all this angle together is 180. Out of this, angle of reflection is angle of incidence, plus this angle is 90, plus this angle is R equal to 180. Then I plus R equal to 90, then R equal to 90 minus I. Angle of refraction, angle of refraction, R equal to 90 minus I. This particular angle is called something like angle of polarization. At that particular angle of polarization, the refracted light ray consists of lot of horizontal vibrations of electric field, but very few vertical vibrations also. But the reflected light consists of, only vertical vibrations of light. This. Thus the reflected light is having only vertical vibrations of electric field. So 100% polarized. Whereas the refracted light has many horizontal vibrations, all horizontal vibrations in the other way, but a very few vertical vibrations too. So this is not completely polarized refracted light, this is partially polarized. But for a particular angle, at a particular angle called polarizing angle, I equal to P, reflected is perpendicular to refracted and reflected is completely polarized. That was the condition that is given in the problem itself. They are perpendicular to each other. That's what we can say is mu equal to sin I by sin R, very definition of refractive index, sin I by there sin R is sin 90 minus I, that is sin I by sin 90 minus I is cos I, that is tan I. Or I equal to, or you can call that angle as P, or P equal to tan inverse of mu is called angle of polarization. So at the polarizing angle, what is the condition that is given to us will happen. So we can now answer the question, right? This is not right, this is not right, because mu equal to tan inverse of mu. The reflected light is polarized with its electric vector perpendicular to plane of incidence. That's what is being said. See this, reflected light is polarized with electric vector parallel to the plane of incidence. The reflected light consists of perpendicular vibrations, whereas the refracted light consists of parallel vibrations. So this is wrong. Perpendicular vibrations are there. So B is correct option. Now I can answer this also. What shall be that value of the polarizing angle? This is called also Brewster's angle. Whatever we have derived is called Brewster's angle also. Angle of polarization actually. This one, polarizing angle, which is also called Brewster's angle. Now, you know, for any medium, any pair of medium, refractive index is always greater than 1. Refractive index is always greater than 1. For tan 45 that is equal to 1. So, for mu this condition to be satisfied, mu has to be greater than 1, angle of incidence, that is Brewster's angle, shall be greater than 45. And then tan 90, what happens to tan 90? Is sin 90 by cos 90. Sin 90 is 1, but cos 90 is 0. 1 by 0 is infinity. That's the maximum possible value. So, it cannot be more than 90 actually, because any refractive index of medium cannot be beyond infinity, right? So, the angle of incidence, Brewster's angle, shall be somewhere in between 45 and 90. So, this is a very important thing. While I am solving these questions, I have discussed almost all parts of this polarization. So, learn this carefully and you can make a comment if needed, right? Thank you.